Okay, today we're going to talk about Chapter 7 from our book, which is about the basics of experimentation. So let's get started with what an independent variable is. An independent variable is what we manipulate, and the levels are the different values that are created. And you have to have at least two levels. So for example, if we were doing a study with Red Bull, if it was a two-level study, then one group would get 2 Red Bulls, and that would be the experimental group. The control group would get 2 glasses of water. If we had an experiment with 3 levels, then we might have one experimental condition where they drink 4 Red Bulls, a second experimental condition where they drink 2 Red Bulls, and a third experimental condition where they drink 2 glasses of water. And so that would be our 3 levels. You have to worry about confounds. That's when an extraneous variable is systematically linked to your independent variable. This is probably not a problem in that most results tend to be very robust. An example with our Red Bull would be the study could be confounded if the people who are participating in the study drank coffee before they came to the study, because again, really what you're measuring is caffeine intake. And so they would be confounding it by drinking caffeine before coming. The dependent variable is what is measured. So in our Red Bull study, continuing with that, it could be heart rate, because caffeine increases your heart rate, or it could be mental acuity, and we could give them a task to measure that, or it could be both. You can have multiple dependent variables in a study also. Operational definitions are very important. This is the meaning of a variable within an experiment. Okay, operational definitions are necessary, but they're always inadequate. And a simple example would show this. So you could say that you're measuring someone's health, and I could give them almost an exhaustive number of tests, but I could still miss something. And so that's why, I mean, I could do, take their blood pressure, their heart rate, cholesterol tests, etc. I could give them a full workup, but I could still miss a major problem that they're having. So operational definitions necessary, but always inadequate. Breaking it down, an experimental operational definition gives you the exact procedure. And so maybe instead of saying I'm using 2 Red Bulls, I might say I'm using 160 milligrams of caffeine, because each Red Bull has 80 milligrams of caffeine, and that's about as much as an 8-ounce cup of coffee, if you're keeping track at home. A measured operational definition is all about how we measure the dependent variable. And so we could say heart rate is being measured by a heart rate monitor, and we would want to be specific, so we might say a chest strap model, so that's something people wear. If we went with mental acuity as our dependent variable, that could be assessed through a standardized anagram task, and an anagram is just words that have been mixed up, and then you have to figure out what the real word is. Well, here comes deja vu, because we've talked about scales of measurement before. Nominal scales just show difference, but they're not quantifiable differences. So the examples we have used before is things like zip codes, or gender, or handedness, or canines could be friendly or shy. That works too. Ordinal scales measure magnitude, so anytime you're putting things into ranking, so class rank, again, I was 52nd out of 532, very excited, top 10%. If I had to rank my favorite restaurants, probably Cheesecake Factory, #1. I absolutely love that place. And then second place, any place that makes Mexican food, I love. Third would be Swagat, which is an Indian restaurant in Kansas City, up in Zona Rosa. It's fantastic. Fourth for me would be Skyline Chili, which is Cincinnati-style chili. Basically, they just add cinnamon. It's not hot chili. And then Fifth would have to be a Chicago-style pizza place. Maybe Dewey's, maybe Uno's. I don't want to start a fight among if anyone's from Chicago. Definitely not Gino's East, though, because that place is just not worth the hype. So anytime you rank something, it's an ordinal scale. An interval scale, again, it shows equal intervals. So, for example, years, but there's no true 0 point. So years are made up of 365 and 1/4 days, but there's no year 0 on any calendar. And so again, Celsius, 0 on Celsius just means freezing point of water. On Fahrenheit, it just means really cold. It doesn't mean no molecular activity. That would be a ratio scale, degrees Kelvin. And again, ratio scales allow us to do things like make proportional statements. So something can be twice as long as something else. We could look at things like reaction time or GPA or heart rate. Heart rate does have an absolute 0, and all of us will eventually have a 0 heart rate. On a cheery note. What is reliability? Reliability is all about consistency. Okay, it's not about validity. It's not about truth. It's just about consistency. So if I go, well, they're using a bathroom scale. If I go to the recreation center and I get on a scale and it says I weigh 30 pounds, and then I step off and it says I weigh 30 pounds again, that's reliable. Okay, it's consistent. Now, again, if I step on and it says I weigh 180, which is what I weigh, and then I step on again and it says that I weigh 150, so I've lost 30 pounds, unless I've lost a limb, that's not reliable, okay? Reliability is all about consistency, and so it doesn't have to be correct, it just has to be consistent in order to be reliable. So inter-rater reliability, let's talk about different types of reliability. The degree to which observers agree on some behavior. So this is like at the Olympics when they have different judges rate ice skating or gymnastics. The degree to which they agree is their inter-rater reliability. And I believe at the Olympics they throw out the highest and lowest score. They should probably throw out, a few years ago, the French judge got bribed by the Russians. So maybe we should toss them out too. Test-retest reliability. You take the same test, is there consistency across the measurement? This is, test-retest is only if it's the same test, though. Okay, some people take the ACT more than once. It's an important point or thing to point out. They're not taking the same test. The questions are different every time. And so that's actually something called parallel forms of the same test. And so that's not test-retest reliability. Test-retest is referring to taking the basically exact same test more than once. Inter-item reliability is different types of items measuring the same information consistently. So on tests, the degree to which multiple choice, essay, short answer, true, false questions all get at the same knowledge, underlying knowledge. Many faculty believe that if a multiple choice test does as well as an essay test, then you may as well give a multiple choice test because you're getting at the same knowledge, but you can get the information back to the students on how well they did, within a few hours with scantrons. But that's inter-item reliability, the extent to which you get consistency among different measurements. Validity is very different. Validity means truth, okay? So are we measuring what we're intending to measure, or are we measuring something else? Now, I mentioned this earlier. What's the relationship between validity and reliability? Well, valid measures have to be reliable, okay? But reliable measures don't have to be valid. Reliable measures just have to be consistent. So again, if I go weigh myself at the rec center and the scale says I weigh 30 pounds, and then I step off, and then I step back on the scale again, and it again says I weigh 30 pounds, that scale is reliable but not valid. Now, it could be valid if I was on the moon, where I would weigh less, but otherwise, on planet Earth, it has some validity issues. So it is reliable, but not valid. Let's talk about different types of validity. Face validity. Do you seem to be measuring what you're intending to measure? This is the weakest type of validity because all it is do you seem to be doing it? Okay. A good example is the ACT. Again, the ACT is very high in face validity because it's a bunch of multiple choice questions, like you read some material and then you answer questions about it. It's high in face validity because that's what you do in college, and it's measuring, how your aptitude for college level work, and so it's testing you in the same way that you're going to be tested in college. So it seems to be measuring what it's supposed to be measuring. Content validity means, are you taking a fair sample of what you intend to measure? So, as they say, an exam over 4 chapters that only has material from chapter 2 has poor content validity. I have a horror story from my undergraduate days. I took AP biology in high school, so I took a biology for majors class as an undergraduate. On one of our tests, the professor put a bunch of genus and species names, and then we had to correctly identify what animal was being described. My problem with it was these genus and species names weren't in the book, and they weren't given in the lecture. And so there was no way that I could know them. So I went up to him after the test and I said, I don't think this test is appropriate because I haven't been exposed to this material. And the professor said, hey, if you want to be a bio major, then you have to know this stuff. And my point was, how am I supposed to know this stuff? If it's not in the book or in the lecture, I can't learn by osmosis. So really what I was questioning was the content validity of the test. I ended up with a C in that class, by the way, and a D in the lab. What's predictive validity? Well, does it predict future performance? Okay. This is different because there's a criterion measure or criterion that you're measuring against. So for example, the LSAT is the criterion measure is passing the bar. So our LSAT score is predictive of people successfully becoming attorneys. It seems to be yes. The MCAT is predictive of passing board exams. Okay, just because you finish medical school doesn't mean you're a doctor. You have to pass board exams. What do you call the person that finishes last in their med school class? Doctor. Although that's not really accurate. It's because technically that's not true. They have to pass board exams. Construct validity is how we accurately represent a construct. That's using the word in the definition. That's not very good. But this is the closest really to what validity truly is. Are you measuring what you think you're measuring, or are you measuring something else? So for example, an intelligence test. What is an intelligence test really measuring? Is it testing your knowledge, or is it testing your test-taking ability, or is it testing your social class, or your assimilation into a particular culture? It's a good question, and people debate these issues. That's construct validity. Are you measuring what you think you're measuring, intelligence, or are you measuring something else? Okay, now we're going to swing to internal validity and the issues associated with it. We've talked about this before. It's our ability to make causal statements. Again, going back to John Stuart Mill, who comes up with the joint method of agreement and difference, so that if you have some event A followed by some event X, then it's possible that A causes X. If A is absent and X is absent, then you can say that A is a necessary and sufficient condition for X. And this is just like our independent and dependent variables, where if the independent variable is present, we would say that it causes a change in the dependent variable, and if it's absent, we see no change in the dependent variable. And so we can say that it's having an effect. Again, you can make a causal statement. Confounding is when extraneous variables systematically interact with our independent variable. So if a good example of an extraneous variable could be location or participants. So if we ran our experimental group for a study at Truman and the control group at a community college, then we have multiple confounds there, both the location that you're testing people at, Truman versus community college, and the type of students that you're testing, Truman students versus community college students. History. What is history as a threat to internal validity? Any event that's outside of your experiment that could have an effect on the people you're studying. So let's say, for example, that we were studying happiness or anxiety right before the 9/11 attacks, and then our study continued right through. So September 11th, 2001. So let's say we were working on it a week before and a week after. You're going to get very different results on happiness or anxiety because the 9/11 attacks made a lot of people unhappy and very anxious. So it's something outside of your experiment that changes your results. The maturation threat is any naturally occurring process, okay, that changes your participants. So a good example of this is if you're doing a study where you give some kids calcium supplements and other kids you don't give them calcium supplements, and then you measure their growth. What you're going to find is your control group who don't get calcium supplements are still going to grow. Okay, so really you're looking at the differential growth. It's not like kids who don't get calcium don't grow. That's the maturation threat, though. That's a physical, natural change that's happening in the children. A testing threat is basically why test-retest reliability is so important. So people becoming familiar with a test and then by being re-exposed to it being different. So if your test-retest reliability is high, then this is no problem at all. If it's low, then the testing threat is definitely a problem. Instrumentation is when you change the measurement instrument, even an improvement in the way you're measuring something. So let me give you an example. In studies of asthma, they use a peak flow meter to measure lung capacity. And this comes in a variety of different forms. You have plastic ones, which essentially give you analog measures, or you can have peak flow meters that are hooked up to computers that give you a digital measure. Going with a digital measure is actually much more accurate, but you can't really compare the analog measures to the digital measures because you're changing the instrument. So that's the confound, is the differences just could come from the way you're measuring lung capacity rather than any actual changes in lung capacity. Statistical regression threat is also called a regression to the mean, and it's easier to understand this through an example. If you're abnormally tall or small for your family, your kids are likely to be taller or smaller. They're likely to regress to whatever the population mean is. So an example from my family, my dad's 5'9", but I'm 6'2", and so I have 3 boys, and they're all 5'10". So they're smaller than me, but they've regressed to the mean, the average male height. Yeah, and that's regression, the regression threat. The selection threat is any time that you depart from random assignment of people to conditions. It's dangerous from an internal validity perspective. Oftentimes with student projects, students will put their friends into the experimental group because that's the interesting group. But it's a huge confound because they're not randomly assigning people to conditions. You're being assigned to conditions based on friendship. And so you can get different results based on that. Subject mortality threat is when people drop out of conditions. It's something called survivor bias too. So in a longitudinal study, let's say with older people, you might have 20 of the original 100 people left in your study after 20 years. Can you generalize from those 20 people to the rest of the population. That's really an external validity issue. But the mortality threat is when you try to generalize from essentially the people who are left in your study to everybody else. So like I said, this is a huge issue in successful aging studies where, subject mortality is literally subject mortality. It's people dying, and so are the people who are dying similar to the people who survive, or are they very different besides the fact that they're dead? Selection interactions are just when you have multiple classical threats to internal validity all happening at the same time. So kind of a worst case scenario. And then the chapter ends by talking about what the method section is. And so again, replication's crucial here. It gives you information. The method section gives you information so that people can replicate the study. And then a part of this is also the apparatus section. When you have specialized equipment, so like we talked about before, the peak flow meter, if you're using that for your study, measuring lung capacity, are you using a digital or analog peak flow meter? And perhaps even what brand are you using so that people are able to replicate your research. So that wraps up Chapter 7, and thanks for listening.